You guys ready to go do some playing with integrals? Are only my basketball guys missing? Oh, and Jack. He was here. Oh, he had to leave early. I knew that. Colby. Well, it's not my writing, but yes, I agree with you. It should probably be U-R-E, which is interesting. So then all the times that anybody uses your, I don't know, go tackle social media on that one and be like, you guys, not only are you spelling it wrong, but you're also not abbreviating correctly. Anyway. You guys already grade 2 and 4? It's easy, right? Okay, U and DU. Number 14. What? Oh, that's just them checking by taking the derivative of the answer to make sure it works. Okay, where's your answer? Right there. Are we okay? Okay. Same thing down. Oh, no, they didn't check here. Never mind. There we go. We okay? Okay. Number 62 and 66. Let me give you a second. Because number 62, do you guys have the directions on that one? Ooh. Some people got confused on number 62, maybe because, probably more because of how the information was given. Is there an integral drawn, written, shown in number 62 right now as is? Is there an integral at all in the problem? No, there's no integral drawn, written, or otherwise shown, right? But what did you need to do to solve for f given f prime? Anti-derive. Now really quickly, I'm just a little worried about how you guys showed your work. Maybe I'm not. Maybe I am. No, I am. I am a little worried. F prime of x can be rewritten as what? dy dx. You guys agree? So the problem is, what should you have done? Multiply dx and then integrated. How did you show your work? Did you go straight here? If so, it's okay. It's okay. But some of you, A, didn't know what to do. B, I'm not sure how you did it. Wait, where's their work? Are we supposed to magically come up with this in our heads? Maybe if you're in BC. But my preference, I don't know where I was going with that. My preference is that you show at least a little bit of work. What did the grad student do who made this answer key? Did it in their head. But what should you probably have done? Done a little baby u sub, yeah? du is equal to negative 2x dx. What did the grad students see? Oh, hey, look, that's du. So what did they do? They skipped ahead, and they didn't solve for dx and plug in and then simplify. They just said, yay, I'm going to pull u out and put du in. And then they got a square root of u du. And they were like, oh, hey, that's u to the 1/2, which is u to the 3/2 times 2/3. And oh, by the way, I'm a smart grad student, and I know who u is, so I'm going to plug him in all at the same time. Do I believe that none of you can do that? No, I believe there are probably like at least 1/3 of you that could probably do that. But am I a little worried that you're going to make mistakes if you do it too quickly all the time? Yes. And some of you, once you start, you're not going to want to stop, and I'm a little worried. Because a lot of mistakes get made. Okay, just be careful. But were we done? Yeah. What's on this side? 1y, aka f of x. Why are we not done? Because they gave us a clue. Good. They gave us a point. Plug in x is 2, plug in y is 7, and what can you find? C is 5/3. What do you need to do to, Kevin, you were reading the directions, to find an equation for f? You have to have the entire equation of f with the c plugged in. With the C plugged in. My last kiddo needing to finish the test is finishing it today after school. And then you'll be able to see your test, and you'll see why I'm making such a point of so many of these little fine details. Because if you're finding the C is not enough. You have to rewrite the entire equation. Okay, choop, 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 choop. Number 66, you guys already check them? Hold on. I'm just checking real quick because some of you use CalcChat. anybody have any questions about how they showed work or why they showed work the way they did? Does anybody have any questions about how they showed work the way they did? Because did anybody notice CalcChat was solving all of their integrals a very different way than us, even though it ended up the same? I saw some head nods. Did the rest of you guys not pay attention? If you didn't, I'm a little worried, because that means either you're not checking CalcChat and getting everything right, or you're not checking CalcChat and you have no clue if you're getting it right or not. So those odds that you have done, you're like, maybe they're right, maybe they're not. I didn't grade them. Or you're stealing from CalcChat. But those of you that nodded your heads, yeah, I noticed something's weird. What's weird? I know, you didn't CalcChat this one, but this is the CalcChat solution, right? It's the back of the book. Yeah. Did you guys catch what Kevin said? You see it? Where's the U? Sub. It's not there. Well, how'd they solve the integral? U sub, but I don't see it. Did no one notice that when you were checking CalcChat? They didn't show any U sub. Well, or they might have every now and then. But some of theirs, there was no U. You're like, what are you doing? Okay, pause. In your work, what should have been shown? U is equal to what? What's du equal? What did I tell you to do next? Solve for dx, solve for dt, get the du over 8t cubed. Why? Because what do we always have to plug in for? The dx or the dt. Always, 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 always. We always have that to plug in for. So we can take whatever this is, whether it's perfect, whether it's off by a constant or off by a variable, you can always take out the dt or the dx and plug in whatever you just got. But what did they do instead? They thought about this. And they said, hey, I have a t cubed and I have a dt. Yay, yay. What don't I have? An 8. Right here in the beginning, right? Was there an 8 anywhere? No. Like, oh man, I can't plug in the du. But don't worry, it's math. Can I put in an 8? Sure. I can put in an 8 and make it match my du as long as I offset with a 1/8. They're multiplying by 1 creatively to make it match their du. They're saying, hey, I had a t cubed dt, that's great and all, but I want an 8. Sweet, there's the 8, there's the 1/8. 1/8 times 8, I haven't changed the value. And they're like, yay, you're du. Yay, you're u to the 1/2. I can do u. That's u to the 3/2 times 2/3. Oh, by the way, there's a 1/8 plus c. This is their way of dealing with u sub. They're doing it, just not showing it. But does our way work also? What would happen if we plugged in du over 8t cubed? What would happen to t cubes? Cancel. What would you do with the 8 that's in the denominator? Make it a 1/8 in the front. And what would be left? Square root of u du. It's the same thing. It's the same thing, just we're using u sub. And why am I having you do this? For those of you that are able to track with what they're doing versus what we're doing. And if you think you like theirs more, here's my problem as to why I changed just a couple years ago to only doing this. I used to do it their way, to be honest. And I was like, nope, that's not smart. That's not smart for high school calc kids. Why? This is so much better with integration on crack. Because integration on crack says what's extra doesn't necessarily all go away to become du. So this way says, okay, fine, I'm taking this, I have to use this, I have to plug it in somehow, and whatever happens, happens. If there's something left, I'll deal with it. If it's a constant, I'll pull it out. If it's a variable, I'll try to do integration on crack and substitute. This way keeps you honest. This creative way, sometimes it works nicely, sometimes it's only off by a constant, and sometimes you're like, wait, it doesn't match, what do I do? This gives you a way to do it every time, no matter what's going on. So please, please, please don't just copy CalcChat. I don't like their way of doing it. Okay? And if you're like, I like their way of doing it, come show me, and I might very well let you keep doing it that way. But I won't necessarily be a fan of the majority of the class trying to do it CalcChat way. Is that okay? Okay. coming back. For those of you that nodded your heads, it's totally fine to ask me that question, but maybe you were waiting until the end of class as far as like, why are they doing it this way? But do they show U sub in number 118? Yeah, they do. So in some of your homework, they did show some U sub. Why? Because they were like, I don't want to do it. Well, this one they could have done mental math style, but that's okay. That's all right. I'll only slightly judge them. Plugging in, plugging in, plugging in. You could have gone all the way back to X's and used the X bounds. You could have changed to U bounds somewhere earlier, but the long story short, you should have matched with A. I think that's the last even, right, cool kids? So here's what we need to do. See if you guys have any questions. Oh, why aren't you working? That's okay. All right, section 4.5, evens or odds. Anything else that we need to see? Section 4.5, evens or odds. Anything else we need to see? Yeah, Dean. 30? Same about 30? Let's look at 30 first. So number 30. We're just solving the differential equation. Oh, hey, it's written with a dy dx already. That's nice. Can I make him a little more flat? There we go. Oh. I would have multiplied dx on the other side, right? Is that what you guys would have done? Now we can integrate. Integral of 1 dy is just, integral of 1 dy is y, yeah? And now I have the integral of, I think I need some u sub. P.S. The work on the answer key that you guys just saw was kind of weird too because they were doing their nifty trick. I'll try to show it to you as we go. What would I tell you to do? Solve for dx to be du over 2x minus 8. What did they do? They took this and compared with that and said, oh, hey, I can factor this guy. We can too. Oh, that's nicer. They said, we just need a 2. So we're going to throw a 2 in and be like, haha, yay, you're going to match the du. I'm going to put a 1/2 on the outside so everything's legal. We would say, why don't you just go ahead and plug in your square root of u? Why don't you have your x minus 4? Why don't you plug in your du over 2x minus 8 and then consider and be like, oh, I need those to, oh, hey, I can make this 2 times x minus 4. Then I can go ahead and reduce. Then I can pull the 1/2 out. Everybody ends up in the same place. But once again, as I just described, I think my way is safer for the tricky ones, especially integration on crack. But once again, multiplying by 2 and 1/2 is valid and will get you there. Because at the end of the day, you do end up with 1/2 times the integral of du over square root of u, or u to the negative 1/2 du. How do I integrate u to the negative 1/2? Yeah, good. I have that 1/2. I need to multiply by, Colby's saying 2 because he's already added 1 to the negative 1/2 and then he's flipped it in his head, right? Is this definite? No, it's indefinite. So therefore I have my plus c. So I end up with the 1/2 times the 2 cancels and the square root of who's u? The c is not in the square root, by the way. There we go. Dun, 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 dun. Number 30, are we cool? Anything else besides number 30? I'm ready. 79. Oh yeah, period 1 didn't like that one either. 79. What do we got? Ooh. Hey kiddos, what does 79 look a lot like? An e to the u. What are we going to practice today? An e to the u. I'm going to show it quick because I said I would. But after today, we're going to get some more practice. So you don't have to perfect it right now. The long story short, if I know the integral of e to the x is e to the x plus c, guess what else I know the integral of? E to the u. So can't I plug this in? be negative 1/2 e to the u du for x's within 0 to 1. What do you guys want? Keep it x's or put in some u bounds? All right, so I'm looking for u of 1 and u of 0. I like doing it this way because my top and my bottom I can just whoosh. U is negative 2 times x. Do you guys like it 0, negative 2? Do you mind? Wait, yes we like it or yes we mind? Okay. If you don't like it, couldn't you switch it and make it a positive? Both ways work. But long story short, what's the integral of e to the u? Himself. So therefore we get to say, oh sweet, it's e to the u. Are we going back to x's? No. Why? Because we have u's ready to plug in. So I have negative 1/2 times e to the negative 2 minus e to the 0. What's anything to the 0 power? 1? Yep, it's 1. So why, oh why, am I going to write the final answer as I switched it. Sorry. E squared minus 1. I did too much mental math. What did I do along the way? Whoa! That, not the same. Yeah, it is. I hope. E to the 0, you guys just told me is 1. True? Couldn't I rewrite this to be negative 1/2 times 1 over e squared minus 1? Couldn't I do this with a common denominator of e squared over e squared? Couldn't I then get negative 1/2 times 1 minus e squared all over e squared? Oh, I didn't put the e squared in the bottom? Sad day. Then I could go ahead and have my 2 with my e squared. My negative goes with the minus 1, and my positive goes with the e squared. Ha! There it is. Go team. Oh. Can you make it match? Hopefully. Anything else? Going once. Anything else? No one's asking the b to the u one? Really? Did you ask that one yesterday? The 3 to the x over 2? Ah. All right. Go team. Here we go. Section 4.6. Thanks, Colby. How's our eyesight? Slowly fading. Too much screen time, huh? So much love in this room. Let's tone it down just a little bit. All right, let's play. Do we have a new forever card? Yeah, we do. Do you have it open and available and ready because you probably don't have it memorized? Yesterday, did I mention there are some tricky ones that you basically just need to memorize? Especially those two, maybe these two. You could make him sine over cosine and do a u sub with u equals cosine, but most of you just want to memorize it. You could do cosine over sine and do a u sub with u equals sine. Most of you just want to memorize it. And these two, just memorize, please, please, please. Shouldn't you be memorizing forevers anyway? Yes. Yes? All right, who's your u in number 2? I know. Whoop-de-doo. Anyway, u equals what? How about you? We're good, right? Now that we have this whole 1 over u du is ln of u, now we're looking at whole denominators being. We kind of did that before. But usually there was like a squared or a cubed, so it was a little bit more obvious. But now we're saying, hey, maybe the whole denominator should be the u. What would your du be? 3x squared? Doing all right, bud? So then my dx is equal to du over negative 3x squared. So when we go plug, is anybody to the point where you're able to like whoosh, whoosh with the x squareds in your mind when you go to plug in? Okay. So we're going to have our x squared over. Yeah, Colby, you're right. Just go carefully. Oh my goodness. I give up. I don't. Don't worry. Don't worry. Yeah, it is. Isn't it? Because my x squareds are going to cancel. Aren't we going to have, oh, careful, not a 3, but a 1/3, true? And then we have our, oh, 1 over u du. Who is that? Yeah, it is. ln of who? ln of u. You guys okay if I go to plug it into u to be 3 minus x cubed? Yeah. Plus c? Is that right? Yes. Is that how they would write it? Maybe. What? Is there something special you can do with ln's when you have numbers multiplied in front of the ln? Ooh, you can make it a power. That's a thing with ln's. Uh-oh, that's not going to work. So what's the or? Could you guys make it match? That's right. And that's right. Why? Logarithms say, hey, if you have an ln of x to the a, it's the same thing as a times ln of x. Ooh, so when I had a number in front, you could make it a power, and a negative 1/3 power says, go in the denominator with a cubed root. Can they play with ln's and primes? Yeah. Be careful. Make it match, make it match, make it match. Can I keep going? Who's you? In number 3. Just in case you still need that one. X over 2. Pause. Oh, but I don't want to know who are you. Although that's a very good question to ponder. But who is you? Who is you? U equals x over 2. du. Ah! That's so annoying. I have to do quotient rule. Bottom to top minus top to bottom all over bottom squared. Or, why don't we just make it a 1/2 x? Because the final, wait, is that what this would do? 2 over 4 is the same thing as just 1/2? So all of you guys who were like, no, I do my quotient rule all the time. Will it work if you don't make a mistake? Can it be easier if you rewrite first? Some of you remember I've been saying this ever since we first learned the quotient rule, but that's okay. E for effort. Wait, we're not done. Ah! dx is equal to 2 du. Yeah? Or not 2d. And I couldn't. I tried. 2 du or not 2 du. It's too complicated. Wouldn't this become 2 on the outside, secant of u on the inside with a du? I just pulled him out. No, wait. We can integrate secant tangent. We can integrate secant squared. One becomes secant, one becomes tangent. But can we integrate secant alone? Not with trig rules, which is why, dun dun dun, did you look at your forever card recently? There's a new formula. Secant squared goes to tangent. Secant tangent goes to secant. That's derivatives backwards. Those are trig. Secant, he's an ln. Why? It's okay. Take his derivative, have some fun, simplify, it'll become that. That's why. Okay. I'm not doing anything else than that. Have fun. Go take a derivative. Long story short, 2 times ln of who? Secant of plus tangent of, and who was my u? X over 2 and x over 2. Dun, 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 dun. That's one way. Or, but where did my absolute values go? If you're squaring it, it's redundant to put the absolute values, and why would they be redundant on an answer? Kevin. How come? Yeah, it's cosecant. I know, it's a struggle. No, you're right. Yeah, you're right, but thanks for calling me on that. Because integral of cosecant is negative ln of cosecant plus cotangent, and integral of secant is positive ln of secant plus tangent. Which is a little bit of a bummer. Well, no, it's not. If we take the integral of cosecant squared. The integral of cosecant squared dx. Who does that go to? Trig time. Integral of cosecant squared of x dx. Cosecant squared goes back to negative cotangent of x plus c. Uh-oh, we need to study our forever cards. Okay, if I write it. So what's the integral of, no, you're okay, It's a lot to hold in. How about cosecant of x cotangent of x dx? Negative x plus c. Now, why am I saying this? We were just talking about the signs, right? Positive or negative. What do you guys notice about both of these? When we're dealing with the c's, what do we end up with? Negatives. When we're dealing with the cosecant, what do we get? No. Shh, come back. Wait a minute. Oh, it's a thing. We can memorize it. Remember, the derivatives of any c's are negative, so the integrals of any c's are negative. Oh. So pause. Maybe it's not about what's in the integral. Maybe it's what comes out. Who does he have? C's. What does he have? A negative. What does he have? Oh, sine. A positive. Oh, cosine. A negative. Ah, look at those c's. Now, what's the one dilemma of this? Look. He has a C. It's a negative. He has a C. It's a negative. Ah. Who's this, though? Wait a minute. Oh, it has a negative? No. Is it good? Oh, never mind. It's good. So any trig integral that has a C antiderivative has a negative. There you go. You're welcome. Remember that. Store it away. Moving on. Number 4. Who's my U? Okay. So go for it. Don't worry. I'm just getting myself lots of room. Oh, we can't see it. No, go for it. Go for x minus 2. You guys are going for it, right? Go for it. I'm coming. I'll go for it too. Oh, some of you are already thinking what I'm thinking. Wait, guys, what do we always do if we have extra stuff? Could we do this? I suppose. I mean, it's 2 times x, which is u plus 2 squared, plus 7 times x, which is u plus 2 minus 3 all over u. It's legal, right? We plugged in our u. We used our denominator like some of you guys thought. We plugged in our du. It didn't really help much, but go team. And then we said, there's tons of x's. We went and found the x, right? Sorry, technically, I mean, I can write dx equals du. Yeah. Okay. How do I antiderive? Because we have to antiderive. That's what an integral means. Take the antiderivative. Couldn't I do u squared plus 4u plus 4? Yeah. Oh. And then I could do 7u plus 14. And I can multiply by 2. So that'd be 2u squared plus 8u plus 7u. So plus 15u plus 8 plus 14 is 22 minus 3 is 19. Double check my math, please. Oh, now it's no big deal. Antiderive. Okay, fine. Antiderive him. And antiderive him. I'm acting like some of you. Don't do that. It's illegal. Is there a division rule for integration? No. Is there a multiplication rule for integration? No. What do you got to do? Split it up. How many of you guys in your minds right now are thinking, oh, you're u to the negative 1. I'm going to distribute u. Okay. How many of you guys are thinking, it's blah times 1 over u. I'm going to distribute 1 over u, 1 over u, 1 over u. How many of you guys are like, I need to divide everybody? Well, half of you aren't thinking anything right. Anyway, love you all, but, okay, hold on. We did this in period 1, and like Colby just said, sometimes I say and you don't think, and so you don't know how to answer. I get that. So hold on, pause. This is important just because of points I had to take off of people's, that's not inspirational. Don't we have to do, is it, guys, help me out, 15, 19, 9, 19. You guys double check my math. You agree with it? Okay. How many of you guys think, way 1, how many of you guys think I should make this u to the negative 1 times, I'm going to take hands in a second, just be pondering, is that how you see the math, way 1? Or there could be way 2 that says, well, you know what? I could actually make this a 1 over u times all of him. So I could do 2u squared plus 15u plus 19 times 1 over u. Or you could think of way number 3. The 2u squared needs to divide, the 15u needs to divide, and the 19 needs to divide. Which way are you considering how to split up the division, which we have to split up? Who thinks way 1 makes sense in their mind the best? Who thinks way 2 makes sense in their brain the best? Who thinks way 3? Okay. I like way 3 the best. But pause. Don't they all get to the same place? Have you guys noticed? Okay, because if I do divide 2u squared over u, hey, guess what? That's 2u. 15u over u, hey, that's 15. 19 over u, hey, that's 19u to the negative 1. Uh-oh, that doesn't work. I want 19 over u. Depending on the problem, one way might be easier than the other, but they all lead you to the same place. How do I integrate? I need u squared over 2 times 2 goes away, plus 15u plus 19, anybody, ln of u, plus c. Who is u? X minus 2 times x minus 2. X minus 2. Do you guys want to see what they probably would have answered, which is not that answer? They probably would have multiplied it all out, and all the constants would have gotten absorbed into the plus c. Do you want to see another way of answering it? Hold on, I'm going to box it. I'm going to go ahead and do a quick little or. We're going to go real fast, just because. It's going to be x squared minus 4x plus 4. We have plus 15x minus 30, and then we have, okay, that's fine. He's not going to change it all. So then they're going to say, okay, I have an x squared. I have a 11x. The 4 goes in the c. The 30 goes in the c. So then we have the 19 ln of x minus 2. Okay. What's another way of getting here? What were we given in the very beginning? What were we given in the very beginning? Oh, an improper fraction? Did anybody remember what I did on the board the other day with division can be helpful? Well, the problem with factoring, I don't think it works so well. I mean, he was kind of on the right. He wasn't totally off. But it's improper, which means we could have just said, oh, hey, you know what? The bottom actually goes in the top at least a few times. I wonder how many times. Well, couldn't we do a 2x? right? And then we'd have a 2x squared minus 4x, and we would do this division, a subtraction. That cancels. Don't make a mistake. 7 minus a negative 4 is 11x. Huh. Bring down the negative 3, and wouldn't that be 11? 11x minus 22, and a negative, and we have, and then that, and negative plus 22. And that's a remainder. Couldn't we have changed that whole thing just to be, oh, hey, it's just 2x plus 11 plus 19 all over x minus 2 dx? I don't see a 15. Look, it's 11x. Look, it's, I have to do a little u sub with, but the u sub's not too bad because u is just x minus 2 and du is just dx. So really this is the integral of 1 over u du times 19. Couldn't we pretty quickly get x squared plus 11x plus 19 ln of u? Sure. It's an improper fraction. Divide first. Okay? Wait, how do you know it's improper? When the top, pre-cal review, is either greater than or equal to the bottom. Wait, what part of the top? The degree. What else do we got? Hey, we have some more fun. You know what? That was already in the last homework anyway. Let's, Let's save these for some back of our homework spiral. Let's go here. Boop. This is what you guys needed help on yesterday, right? Yep, another forever. I think it shows up in this homework, which makes sense as to why I cover it in this homework, but it showed up in the last homework too, and I apologize. Yep, this is forever number 40. 40? 40. Ooh, 10 more left. Yeah, we have to end by our mock AP. I need to remember. It's in the syllabus.
Wait, so is it your guys' decision as teachers to have a mock, or do you have to?
I think it's April 6th, which is the week before AP Chem.
April 6th? Wait a minute. That's the week before. My sister's birthday is That's March 6th. March 6th. No, I do. March 6th. That's March 6th. I can't speak English properly. That's okay, March 6th. That's so bad. It's January 12th. That's so bad. I know, like, that's crazy.
Hey guys, as much as I love this whole anxious whatever is going down, let's not. Because don't worry, I got you. You gotta take one day at a time. Be faithful with what you have now. Everything else will work out. So, we have the derivative of b to the u is boo, lim, oo. That's the derivative. Where does the integral come from? Well, if you were just to go from boo back to boo because boo goes to boo, if you were to take the derivative of boo, wouldn't you have a boo and a limb that's not there? Where's the limb? Where's the L and the B? Not there. Oh, when there's constants that aren't going to be there, we actually just kind of put the 1 over. Is that a thing? Yeah, that is a thing, because we can take, like the back of the book, like a grad student would do. We would say, you know what, to go backwards, we have to have the ln of b, but we can't randomly put in an ln of b without offsetting. We can put in an ln of b if we offset. We have to offset, like we have to offset with n plus 1 with our power rule. We have to divide by the extra constant so that we can go back to, oh, hey, it's b to the u times 1 over ln of b plus c. Am I going to make you memorize where this comes from? No, I'm going to just make you memorize the rules. But some of you, your brains work better when you know why. Some of you. U equals. But not all of you can hold in the why as well as the memorize. So that's okay. We do what we can. What ends up happening? I don't know. We plug in stuff, right? We have e to the u times a du, but he needs a negative sign. And then we have our, wait, can I write 3 and 4? It's totally illegal. I could put a comma and I can put x within 3 to 4. Or I could come over here and do what some of you are telling me, which is plug into u's, which I can do too. Plugging in 4 is -1. Plugging in 3 is 0. And some of you that are like, I don't like it when it's backwards, you can go ahead and instead of plugging in -1 and 0, you can flip it and make it positive. And then you end up with e to the u. Those are u's. Don't go back. If you keep them in x's, you better go back. And I get e to the 0 minus e to the -1, which is 1 minus 1 over e, which you know they would write that e minus 1 over e. All right, cool kids. Woo! Go bust out homework number 31. Technically, you have grace. Should you take advantage of that grace? I wouldn't right now. Bye, Abby. See you later. Oh, not bye. Hi, Abby. What's your question? Everybody else, bye. See you later.
Bye, Abby. Bye.